Hello and welcome to a further online learning session with the topic ClimaECO, room climate control with ventilation and air quality. My name is Thorsten Reibel from the Building Academy Smart Buildings, and together with us is Jürgen Schilder, and we will share the session today. The session takes around 45 minutes, and as always, if you have any questions, please send it in the chat to all participants so that everybody can see your question and we try to answer already during the session or later than at the end. As always, the session will be recorded and published later, and I still send you today the first feedback email with the PDF of the presentation, and later of course we will get then the full feedback email together with the recording of the video as well. So let's start with a small overview of our HVAC solution called ClimaECO in ABB plus KNX. We have done a lot of trainings and sessions around this topic already, and you might know that ClimaECO is a holistic solution based on KNX for heating, ventilation, air conditioning, for, let me say, also automation solutions behind HVAC. So it's a seamlessly integrated room automation solution for distribution, for, let me say, also the generation of the hot and cold water, and of course also room automation. We have a lot of products here behind. You see an overview of different sensors, valve drive controllers, fan coil controllers, and so on. As mentioned, we have done a lot of sessions around this topic already, so please have a look at our training and qualification database. You find the link here. So here an overview with the images of the products. On the left you see the more room-oriented components, the sensors with controller inside, presence sectors and so on. Here more the actuators we need for controlling. And also on the right side the part which is more automation, which is more distribution, and also the generation part via the boiler chill interface is supported. And today we talk about the following products: some selected room temperature controller, which includes also measurement of CO2 air quality and humidity, and also control for these functions. Here you have an air quality sensor, the same functionality in principle, but no operation possible. And then we come to the actuator part, the blower actuator, which allows us directly to control fans, so the ventilation. So let's have a look to the topic air quality in general, first of all, because room or air quality is a big topic or an important planning parameter for energy efficient buildings. In Europe we have a so-called European Building Directive, which requires not only good room temperature control, but it requires also taking into account the air quality, so the room air quality, which is also very important here. And what you have nowadays in modern buildings, you have a very tight situation regarding insulation. Means there is no natural ventilation continuously running, and this results often in very low air quality levels if you do not do anything around forced ventilation. And one parameter for this topic is the CO2 concentration in a room. So what happens in a room regarding CO2 concentration? If we are inside, we increase the CO2 concentration during respiration. So, and a high CO2 concentration influences the well-being of the people dramatically. Especially in rooms where a lot of people are inside, like school rooms, conference rooms, or open space offices. We need a provision of additionally fresh air, otherwise we will not have a good situation regarding CO2 concentration. And you see here on the right a typical situation: if many people are in the room, the level of CO2 is increasing to a value which is not comfortable anymore, or maybe also dangerous. So what happens in more details regarding CO2 in a room? We rise the CO2 concentration by breathing, and everybody has to breathe, of course. In a normal room air we have 21% oxygen and around 0.035% carbon dioxide, CO2. So when we breathe now, we reduce the air. We are breathing out from 21 to 16%, but we increase the CO2 concentration by 100 times. Means from 0.035% to almost 4%, so the air we breathe out. So you see it's a dramatic change, and as we have seen also the CO2 level in the room can change dramatically. So another parameter is the humidity in the room. The relative humidity is the value we measure here, and it's also an important parameter for considering the air quality. And it's also depending on temperature. So high humidity in a room, you know it from hot summer days with high humidity is very uncomfortable for the human being, but can be also problematic due to any condensation for the building itself, but also for the furniture. And if you have a look to the definition of relative humidity, it's called like this: the ratio of the current water vapor content of the air expressed in percentage relative humidity to the maximum possible vapor content at the same temperature. And this depends on the temperature. High temperature, or the air with high temperature, can absorb more humidity than air with low temperature. So this you see here on the right side, the graph, relation between ambient temperature and relative humidity. The higher the temperature is, the less relative humidity is accepted, because you have already in high temperature higher humidity. So this goes down here. And you see, we have an acceptable range, but also a comfortable range. And if you exceed these ranges, then it's getting really uncomfortable in the room. Let's have an example. So if a human being is in a room, you will breathe out around half a liter of air, and this 18 times per minute. So let's take a seminar room with around 140 cubic meters without supply of fresh air, and 30 persons are inside. For 1 hour, the oxygen concentration will rise only to, or will go down, not rise, will go down only to 20.5% from 21%, but the CO2 concentration is increasing dramatically to about 4,500 ppm. So ppm is a unit for CO2 concentration, part per million, and this is not comfortable anymore. So starting from around 2,000 ppm, you have already problems in the room. Also with lower values, you might have already tiredness or headaches. So this one or these values have to be avoided, of course. Yeah, starting from 800 ppm, which is not very much, you can get already tiredness. And the German standards, for example, prescribes that in a room per person, provision of outside air of around 30 cubic meters per hour has to be available. So you need forced ventilation typically, or you have to open very often the window of the room. Yeah? So this is not possible to reach with a current building standard. And as mentioned, the reason is this high tightness of the rooms, of the buildings, very tightened rooms we have, walls we have. So a controlled ventilation is needed. Yeah, here we see a graph, what happens in a room, a sleeping room in this case, with 2 persons inside over the night with closed windows. You see also here a significant increase of the CO2 concentration, and then it goes down if you open the window for ventilation. So this I would like to say to introduce you a bit into the topic. I would hand over now to Jürgen. Jürgen will go into more details of the real solution with ABB Ibex KNX and with our products. I hand over. Just a moment, please.
Hello and welcome. Jürgen Schilder is speaking. Thank you, Thorsten, for the introduction and the useful information on the comfortable room climate control with the influence of the CO2 concentration on people's well-being. Today I will introduce you the different air quality sensors and the blower actuators and how they work together. These are the air quality sensor LGS/A, the 6109/28, the control element ABB Tenton SBC/U, and of course the blower actuators FCL/S. I will show you the most important device properties, the ETS parameter settings, and how the group addresses are linked to each other. Let me start now with an overview of ventilation and air quality. On the left side, we have a typical room, like here a meeting room or office building, and in such a room we have some physical values, like temperature, humidity, CO2 concentration, or also air pressure. By using an air quality sensor, we can measure these physical values and send the values via telegrams to KNX to make it visible on a visualization or on a panel or somewhere else. So the end user can see these values. But we want to do more. These values can be used internal by using these controllers depending if the room is occupied or via time switch, and can control fans and blowers by using such a typical blower actuator, a fan coil controller, our room master or the room controller. But not only a blower or fan, but also windows, or slats or roof hatches, for example, skylights or roof windows. These devices can be controlled by a shutter actuator. So this can be, of course, also combined in a building. But today we want to put the focus here on our blower actuator FCLS. Here you can see the recording of measuring the CO2 concentration and the relative humidity here in my home office. This morning, during the first session today, I have recorded here the CO2 concentration. You can see we started here at 9:30. I have closed here my window and the door to the living room, and you can see here the rising of the CO2 concentration until this morning session ends. And we have here a value about 1300 ppm. And exactly on this time, I open the window and you can see the falling here of the CO2 concentration. And similar here on the right side, the relative humidity. Also here rising and then opening the window and falling here the relative humidity. So when you have a look here on this recording, usually we say, please open the window to get fresh air inside. But remember Torsten's words, the fresh air, the oxygen is not important. The problem is the CO2 concentration. We have to open the window, or we need a blower, for example, that the CO2 goes out of the room. That's the correct statement. CO2 out of the room. Good, then let's come to the air quality sensors. Such typical air quality sensors, like you can see here on the right side, measures at first the room temperature and can be used also for typical room temperature control together with a, for example, fan coil controller or valve drive controller. Additionally, the value can be used with the internal controller for CO2 control and also for relative humidity. We have additional controllers inside. This can be a controller which can be parameterized for a single, 2 or 3 stage fan, for example, when you use a typical switch actuator. A switch actuator can then listen to the telegrams here when you parameterize the controller as a type single, 2 or 3 stage. When we use our blower actuator or fan coil controller, then we can use the PI controller and have a better, of course, controlling system. So then we look here on our air quality sensor with the room temperature controller inside LGS/A12. This is a surface mounted device with all features inside, room temperature controller, and of course also controller here for our relative humidity and for our CO2 concentration. The bus couple unit is integrated. There are no operating elements, but the end user can see here via the LEDs the threshold of the CO2 and humidity. The first LED is for our CO2 concentration and the second one is here for our relative humidity. Green means we can set a threshold, and the LED is here green. Then we have a kind of warning, orange, and the third threshold, which gives us a red LED for CO2 and relative humidity, said okay, it's time maybe to do something or open the window or something is not okay here. So the sensor inside measures the CO2 concentration between 390 and 10,000 ppm, the relative humidity between 0 and 100%, and temperature between 0 and 50 degrees. And of course, these values are also sent on KNX bus for visualization, for example. Plus some more, of course, features are possible here in this extensive ETS application. So the similar parameter settings we have here in our control element 6109/28. It measures also this value CO2, relative humidity, and also you see here the air pressure between 300 hectopascal and 1100, and send the values here also on KNX. The device can be used also for room temperature control, and the same like before, we have here a controller inside for CO2 and also relative humidity. Plus, additional, we have here 5 inputs. The inputs can be used for binary or analog sensors, like a typical switch, or also here for external temperature sensor, like a PT1000. So the device is available with a different cover plate. Like here, this is a cover plate which fits to the sensor range solo, and here in studio white. Of course, we have here some more ranges and also other colors available. And our third air quality sensor is a so-called control element ABB Tenton. The Tenton is available with 6 or here with 10 buttons. These buttons can be used for typical functions like switching, dimming, controlling blinds, sending values, call scenes, or also for internal operating the to control the internal RTC functions. In the display, we can see here like 850. This is here our CO2 concentration, and there's a time function inside that every 5 or 10 seconds is switched to the relative humidity. So the end user can see both the humidity and of course the CO2 concentration plus the actual room temperature here. So the device has also built in a bus couple unit, and it's possible here to labeling here these fields. And the device has nearly the same ETS application like the 2 devices before. So now I look here on this ETS parameter settings of this ABB Tenton. We have here the parameters for room temperature control, for our push buttons, but we look here on the CO2 sensor. If we want to use the CO2 sensor, then we click here on the button active, and then we get here the sub parameters windows and here the parameters for the CO2 sensors. Like for example, if we want to send it cyclically every minute, every 10 minutes, or when the value change here plus minus 20 ppm, 100 or 500. This can be set here. So additionally, we can then activate our controller, and you see here we have the different controller types for single stage, 2 stage, 3 stage. Then we can control here, for example, a fan which is connected to a switch actuator. And then the output control value can be, for example, a 1-bit value, a 1 byte, but also a scene. But in our example, we want to use the PI controller. So we change here to PI, and then we get here the parameters for PI, for example, to set the P value and also the I value. And we can set here the parameter of sending the value when it changes plus minus 1%, 2%, 5%, and cyclically every minute, 5 minutes, 10 minutes, or other values. So when we look on the group objects, then you get at first the group object CO2 value. This here is a 2-byte value according to the KNX data point type 9008 parts per million. This is a special data point type here for our CO2. Plus, when we enable our CO2 controller, the PI, then we get here the control value as an output signal from 0 to 100% here, because it's a typically 1-byte control value, like you know it from a typical room temperature controller. So next page, we come here to the relative humidity. The same principle like before. We can activate the sensor. Then of course we can set here again the typical sending parameters. When it changes plus minus 1%, 2% of the relative humidity every minute, 5 minutes, 10 minutes, and so on. Then the same, we can also enable here our controller as a single stage, 2 stage, 3 stage, and PI. So when we say PI, then we can also specify should it be in percent or as in byte. Typically, or the standard will be percent because it's a value from 0 to 100%. And then when we look here on our group object, we get at first the relative humidity group object, 2 bytes in humidity. This here is the data point type 9007. And for our PI controller, you see we get here the 1 byte length in percent between 0 and 100%. Plus, of course, some more parameters, but today we are only interested in the CO2 and relative humidity parameters. Good, then let's come to the blower actuator FCL/S X611. The X means it can be used for controlling one blower or with a for two independent blowers. And this device is of course used in special ventilation applications. So in principle, it is similar like a switch actuator. We have relays inside, but we have a special logic, ETS application, to control here blowers or fans. Later you will see in the parameters, we have to set some parameters which we get here from our technical data sheet of the motor. And when you have a switch actuator and you control a 3-speed fan, this will not work or make problems. For this case, we have here these special blower actuators. So of course we can control typically fans and blowers, plus we have here some more outputs, typically 6 amps outputs for also switching loads, like a typical application will be a blower main switch. So you control the speeds of the blower here via these 3 outputs, speed 1, 2 and 3, and the main switch can be switched on here via this relay. Or the relay can be used for controlling a damper or a valve, also possible. And the not used output can be also used as switch actuator outputs, like here with a device with 2 outputs to control here our fan. So very important, with these devices we can control only a single phase fan. So we come here in with our phase and then we have here the outputs for our fan. So, and the device of course receives the control value from our air quality sensor via 1 byte percent 0 to 100%. Additionally, the devices can be also operated by rockers in the so-called direct operation mode, which I show you later. So then let's have a look on these 2 different hardware devices. On the left side we have the FCLS 1611. It means we can the device can control 1 3-speed fan plus 1 switching output here for the blower main switch or valve or damper something. The second device is the FCLS 2611. Here 2 3-speed fans plus 1 switching output can be here controlled. So, or what is also possible, only a 1-speed fan plus 5 switching outputs. So in the ETS parameter you can say, okay, I have not a second fan, and then these 3 speeds can be used as 3 independent switching outputs. So we have the possibility for 1 3-speed fan plus 5 independent switch outputs, also possible. So now on this slide you can see the so-called connection diagram. So on the left we see our device for controlling 1 fan. We see here the incoming phase for our single phase fan and then the 3 outputs for our fan, plus a second output here for switching a load, like for example the main switch of the blower. The FCLS with 2 outputs can be used to control 2 independent fans plus 2 independent switching outputs, or you can parameterize that here the second fan is not used, then we get 3 more independent switching outputs. So we have maximum here 5 switching outputs. So then let's come to some special parameters in a blower actuator. So very important is the operating mode of the motor. So the most common operating mode is the so-called changeover switching mode. So what does it mean? When we switch on the motor in fan speed number 1, only here the first output is closed and the other one are here open. So when we switch in fan speed number 2, at first this one here switches off, and then we have a short time, which is typically here 500 milliseconds, and then the second output is switched on and the motor goes in the fan speed number 2. Now when we switch to the fan speed number 3, this output here will be switched off, and after again this waiting time the fan speed number 3 is switched on. So this is here very important, the principle how the motor must be controlled. So you have to take the technical data sheet of the motor and read, does the motor needs this principle or works he like this step switch principle. Step switch means fan speed number 1, output is here on, fan speed number 2, output 1 and 2 are on, and fan speed number 3, all outputs are on. So this is here the principle of step switch. And the device will be delivered to prevent the mistake here as a default parameter into the change switch operating mode. So then let's come to these 2, let me say, different modes of this blower actuator. One is so-called the direct operation. Direct means via a control button or push button or presence detector, for example, we can manually switch here a fan speed. So we can do it via 1-bit object for each fan speed. So when you enable this in the ETS parameter setting, then we get here the object number 11, which is fan speed number 1, number 12 is fan speed number 2, and fan speed number 3 is here the object number 13. So if when this object here, fan speed number 1, receives a 0, then the motor or the fan stops. If he receives the value 1, then he goes in the speed number 1. If this object here, switch speed number 2, receives the value 1, then he goes in fan speed number 2. And this object here, switch speed number 3, receives the value 1, then he goes in fan speed number 3. So we have here the possibility with 3 1-bit telegrams to control here the fan in speed number 1, 2, or 3. Another possibility is to use 1-bit object for going up and down. This also you enable it in the ETS, and then you get here the object number 14, and via this object we can go with the fan speed up and down. Value number 1 means go up, and fan speed and the value number 0 go down with the fan speed. So the left side of a, let me say, of a rocker, we can go up, and on the right side, for example, down. And the third possibility is to use a 1-byte group address for changing the fan speed. And depending the value of this byte, the fan or the blower actuator goes in speed number 1, 2, or 3. So then we have here the object number 10. You see here counter pulses. The value number 1 means fan speed number 1, value number 2, fan speed 2, value number 3, fan speed 3. Value 4 to 255 will do nothing. And value 0 go off the fan. So this is the principle of the so-called direct operation. And another possibility is to use the automatic control. So in the automatic control, then we need a controller like our air quality sensor, which calculates our control value and send it as a value between 0 and 100% here to the blower actuator. So the blower actuator can listen not only to one control value, he can listen to 2 control values. Maybe one control value is coming from our CO2 controller, and the second one is coming from the relative humidity controller. So, and depending on a parameter, we can say use always the largest value or switch between these 2 control values. When we say switch, then we get here another object, which is number 31. You see here toggle control value A or B. And of course, we have some other standard features like the monitoring of the control value. Does the blower actuator receive it every minute? And if he not receive the value, then maybe go to 30% or 50%. Such things are possible. We can have limitations, maximum 4 limitations. These are really nice additional functions which can be used, let me say, in a hotel room during the night. During the night, the hotel guest he wants to sleep, and if the fan blows in the speed number 3, this is sometimes a little bit noisy. So then via a time switch, we can activate a limitation, like a so-called sleeping limitation. And in the sleeping limitation, we can say, okay, the fan can run in the speed 2, 1, or he can be off. He can never run in the speed number 3. If the control value is 100%, he will go maximum to the speed number 2 to reduce the noise in the room. Or for example, if the room is not occupied, we are leaving our hotel room, we remove the key card from the key card reader and leave the hotel room. So, and then we can activate another limitation, a so-called, let me say, absence limitation, and the fan runs always in the speed number 1. So we have a kind of ventilation inside the room if the room is not occupied and the hotel guest is absent. So very nice feature here to use these limitations. And of course, we get a 1-bit object to switch between the automatic and our direct operation. This is here our object number 26. Good, then let's come to some parameters of the blower actuator. Of course, we have some typical parameters at the beginning. Now let me start here with the fan. At first, we can start here with setting the parameter. Do we have a multi-level fan or only 1-level fan? Typically, multi-level means maximum 3 fan speeds. And here, this is one of the important parameter, the operating mode of the fan. So please have a look in the technical data sheet if it works according to the changeover switch principle or step switch. When we say change over, then we get here a parameter to set a delay time between switching here our different speeds. And the typical behavior when we have bus voltage failure or bus voltage recovery. So plus some more functions like here a forced operation which can be activated via 1-bit telegram. And here we can activate our different operation modes like the automatic operation, yes, and if we want to use also the direct operation, then we can also enable it here. Plus some more features like here a startup or run-on behavior can also be here enabled. So here you can see some of these objects we have. Typically we have, when we have enabled it, also the run-on, the forced operation objects. We get some status information. One is a status byte, which gives us the indication of the operating mode, plus some feedback of the fan speed. At first we have one status object. If the fan is on off, it means fan speed 1 or 2 or 3, then this object has the value 1. We have then a 1 byte object for our fan speed. You see it's a byte. The value of the byte depends on the speed, 1, 2 or 3 or 0 of course. And we have 1-bit objects, which gives us the information if in the speed number 1, 2 or 3, plus here our byte for some more status information. So then we have additionally an output or more outputs for switching functions. So we have here some basic functions for switching, like time functions, staircase functions, for example, we have here inside, and also some features, for example, for bus voltage recovery or bus voltage failure. This is for typically switching functions. So then let's come to an example about room air quality. So at first I want to give you an example how we have to link the group addresses between our control element when we use here the push buttons for this direct operation, and the second step, so a second example for automatic control. And the third example will be if we mix both. Mix means we use the automatic control plus the end user has the possibility to operate the fan here via these buttons. So then let's start with the first example for the so-called direct operation. Direct means we have here no air quality sensor, nothing. We want to control manually or direct the speeds here of the fan. So we can do it in three different possibilities. It depends here our ETS parameter settings. So when we go to fan, direct operation, and then we have here the possibility to enable maximum three objects. One is, for example, here for the speed in 1-bit information. Then we get here for up and down, and here in 1 byte. So I have here enabled all these 3 parameters, and then you will see we get here the object for speed number 1, speed number 2, number 3. And now when this object number 12, for example, receives a value number 1, and then the fan coil, the blower actuator goes in the fan speed number 2. So this is exactly what we can use here with the rocker number 1 and 2. So when I press here on the left side, I send the 1-bit information with the value 0, then he goes off. On the right side, I send an on telegram, then he goes in the speed number 1. And the same here, 2 and 3, I have to parameterize that here on the left side, I send the 1-bit with the value 1, and here with the value 1, which means here speed number 3. So if I want to use the going up and down function, then I need again here one rocker, maybe on the left side up. So here send always the value 1, and on the right side for going down send the value 0. Then we use here this object number 14, fan speed up and down. So for using this 1 byte group object, advantages here we need only one group address, the same group address. We link it to this rocker and this one here, and by sending a value 0, 1, 2 or 3, the actuator goes here in the desired fan speed. So these are the 3 different possibilities. We can control a fan direct via control element, via presence detector, or also a time switch, also possible. So then let's come to the linking of the group addresses. So at first we want to control it via the 1-bit object, speed number 1, 2 and 3, and then I have to press to link a group address here from our first rocker, which is S1, S2 on the right side, a group address with the value 1 and 0, and here another group address for the button S2 and S4, here for linking then for fan speed number 2 and 3. So with this possibility I can use typically very easy 1-bit telegrams. So for going up and down, I need another 1-bit telegram. Here with the value 1 means on, going fan speed up, and value 0, go fan speed down. Down means from 0 to 1 and off, of course. When I'm on speed number 1 and I go down again, and then the fan goes off. Or by using a 1 byte, then I can use, of course, here the same group address. And depending on the value of the group address, the fan goes here in the speed 0, 1, 2, or 3. So I have to set here parameter, left side send the value 0, here the value 1, and in the last rocker left value number 2, and here value number 3. Plus linking the group addresses for the status LEDs if I want, though the LED shows me the status of the fan speed. Good, then let's come to the second example. Here I want to use an air quality sensor, and I don't want to operate it manually, only a complete automatic control. So I have here a CO2 in my room. He measures it, and depending if it's automatic mode or not, he sends the control value to my blower actuator. It's a control value between 0 and 100%. And then in the parameters of my blower actuator, I have to set here the thresholds. Because here he receives 0 to 100%, and then I can send here a threshold of speed number 1 of 10%. It means between 10 and 30% he goes in fan speed number 1. Between 30 and 70 he goes into the fan speed number 2. And higher than 70% he goes in the fan speed number 3. Plus some parameters for the hysterese or minimum dwell period in a fan speed can be also set here in seconds. And the next parameter is here the number of control valve inputs. Typically I have only one control input, like here, sent by my air quality sensor. I have then linked the group address here to this input control value in percent. So, and to do it here in an overview, how to link here the group addresses. At first I need here a 1-bit group address for switching into the automatic mode, yes or not. So when I switch here in the automatic mode, then the blower actuator is listening to the control value and goes in fan speed 0 to 3. When I deactivate here the auto function, he is not listening any longer to this control value and he stops, for example. So what else? The status of the LED, which gives the end user information. The LED here is on or off if the automatic mode is on or not. So the control value, of course, must be linked from this object, control value, 1 byte, 0 to 100%, here to the control value of the blower actuator. That's all. Only one group address. Same like a room temperature control principle. So, and of course, if we want to use here the value as a 2-byte value to see it on a visualization or on a smart touch or room touch, for example, then we have to link here group address and make it visible on our panel. So if you want, you can use also here then the status information. Status fan is on off, or the speed as a 1-bit information or 1 byte, and also possible. So then we come to the mix of these two possibilities, the so-called direct operation, that the end user can change here the speed by left side up and the right side down, and of course the automatic control. So here in our room we want to measure the CO2 concentration and the relative humidity using PI control, and then the air quality sensor here, our Tenton, should send a CO2 control value and a relative humidity control value. So in our ETS, in the parameters of the room temperature controller or air quality sensor, we have to enable here number of control value inputs 2, because he receives 2 control values, CO2 and relative humidity. So then we have to select here, should he use the largest value or switch between these 2 values. But when you say switch, then we get additional a 1-bit object to say use here the control value for CO2 or for humidity. But I think the better way is to say the largest value. So then you will see we get only here these objects for fan, speed up and down, for the automatic on and off, and control value A for CO2 and control value B for humidity. So now when we go here to the overview how to link the group addresses. So at first we need again a 1-bit group object to activate or deactivate our automatic mode, to link it here from the control element, the first rocker, to the blower. and back a status group address, which makes sense. And then the end user can see if the automatic mode here with this LED or this LED is on or off. So for the direct operation via the second rocker here, for changing the fan speed up and down, we need a 1-bit group address and link it here to the object fan speed up and down. With the value 1 going fan speed up, value 0 going fan speed down. So and then we come to the CO2 control value. It's a value between 0 and 100%. We have to link it with the group address control value A or B, doesn't matter. We say, for example, here A, and the value in 2 bytes in ppm, which is here our 9008 data point type, can be used to make it visible on our room touch, smart touch, or visualization. So the second control value, which is here calculated for our relative humidity, is linked then between 0 and 100% here to our fan A control value B. And if you want to see the relative humidity somewhere on a panel, then also here link a group address and send it on KNX. So plus the status information can send from the blower actuator into the KNX world, like the status fan is on off, the fan speed is a byte, the speed 1, 2, 3 as a 1-bit information, and the status byte mode of the blower actuator will be also for visualization or for further information. Good, so far this was my presentation on room climate control with ventilation and air quality. I hope to see you next Thursday, because on Thursday morning in the afternoon I give a practical demonstration of the content which I have shown today. So I have here additional camera, I have here training boards with the ABB Tenton and a blower actuator, and by pressing the rockers or simulating the CO2 concentration humidity, then you can see exactly here the behavior of the blower actuator. So please register and join again the session next Thursday. So far, I would like to say thank you for your participation, and I hand back now to Thorsten.
Yeah, thank you, Jürgen, for this presentation of the topic room climate control with ventilation and air quality. We have seen right now, the kind of basic functions we can do easily with KNX in terms of ventilation. You know, we have these components, these sensors and controller to take care of not only room temperature control, but also air quality and humidity. And with a blower actuator, we can directly control a fan, a 3-step fan typically, and can implement the solution, what was shown by Jürgen. Of course, you can still extend the solutions, for example, using analog actuator, which allows to control continuously the fan speed via 0 to 10, for example. Thanks to our building automation controller BUX, we can also create more powerful solutions with software functions inside this component. Remember, we have here also libraries for HVAC solutions available on the programming language of the building automation controller. We have additional in and outputs here available to connect any further sensors, or let me say also controllers, whatever you want. This allows you to extend also a KNX solution with this component here. If you have projects with a very powerful HVAC solution required, with, let me say, real air conditioning and ventilation, where you have also humidification and dehumidification necessary, where you have heat exchanger, where you have maybe pressure measurement also needed, then we have a further solution in our building automation range, ABB Cylon. So our building automation solution, building management system, ABB Cylon, allows to do here also a lot more and is on the highest level for any air conditioning and ventilation solutions. Okay, allow me to go to the final slides as always. So if you need any further information about our products, don't forget our homepage, abb.com/knx, where you find everything around the products. All our training material is always stored in our training and qualification database. Also this a session will be stored there very soon. And also all older of former presentations we have done, webinars, online learning session are available as a presentation, but also as a video recording. In addition, all these videos are also available on our YouTube channel, ABB Home and Building Automation. In addition, I would like to give you the information that we have a so-called software repository available on our homepage. It's in principle an Excel sheet which contains mainly all existing ETS applications for our ABB IBAS KNX devices. From old products to the current products, any application will be available. So if you have to get an older ETS application for an older product, for example, you can go here directly, type in the name of the product, and then it will be available for you with a link, and you can use it then later. So it's mainly for ABB IBAS KNX, for our Welcome IP and Free at Home system. Here you find firmware versions available for these systems. There are no applications, of course, and this is only available for the KNX devices. Yeah, go to our homepage, abb.com/KNX. Under additional materials, downloads for KNX, you find this Excel sheet software repository. You can download it on your PC, and we update this file continuously if needed. What else happens the next time? Light and Building Fair will come in October this year, from the 2nd to the 6th of October, in principle like the years before. So we have a real fair now. We can come together again. And of course, ABB has a big booth there on hall number 12. It's a new hall, the same way as before. So maybe you can come to Germany and then we can see each other again. In addition, there will be also a kind of virtual fair, so-called Light and Building Digital Extension. This will run also from the 2nd to the 6th, but also some days later it will be available. Have a look on the homepage of the Light and Building Fair. You get there some more information. I think there will be kind of virtual fair as well in terms of presentations maybe, and you can also contact persons there. Have a look there. I think also an exciting additional activity here for the Light and Building Fair. What will be done next by us, by Jürgen and myself? So we continue with our practical learning session for this topic on Thursday this week. So the same topic in principle, but we talk not in details like we did it today. So this presentation about this topic, it's mainly a demonstration of these solutions we have shown today, and also the ETS will be a more detailed part here. Then we will continue with the application controller ACS, again with an online learning session on the 10th of May. So more presentation, and then we'll continue 2 days later on the 12th of May with a demonstration of the solution around the application controller ACS. And in June, we would like to start with or continue with the ETS 6. So a new version available since autumn last year. We would like to give you here a qualified introduction and also practical view in the software, together with a 1-hour webinar. Then I say thank you for your participation. Hope to see you next time. Thank you. Bye-bye. Ciao.